Greeting to everyone. We are the Oppenheimers from College Matriculasi Negeri Sembilan. Today, we are going to present about our OPS battery, which are biomass battery by using sugarcane baggers. Some of our main objectives in making this biomass battery is to create a battery cell by using biomass as its primary energy source, to reduce the emission of greenhouse gases, and also to reduce pollution that is caused by battery and biomass waste. We have decided to move forward with this innovation due to many factors, and some of which include, firstly, greenhouse effect and global warming. This is because normal store-bought batteries such as lithium-based batteries emit high amount of carbon dioxide during the production. Secondly, pollution. This factor was considered the most because in Penang and in Selangor, Malaysia, a factory was caught on fire due to the storage of batteries, which has greatly affected the lives of people who are living nearby. The fire has contributed to air pollution. Lastly, health and respiratory issue. When disposed of in an unlined landfill, a battery can leach its toxic constituents and contaminate groundwater, resulting in possible exposure to humans and be the cause of various diseases. As example, lead pollution that caused in Kampung Jejaru, Malaysia, where the villagers have been affected by lead pollution from a nearby battery factory. Besides that, pollutions were also caused by recycling cadmium, lithium batteries illegally in a factory at Penang. Malaysia is a country with abundant biomass resources. Here are a few examples of biomass resources found here in Malaysia itself. Biomass resources can be used continuously without limits because it can be found in our everyday surroundings, and carbon is produced every day through the process of photosynthesis. Carbon can be concluded as a main substance in the process of generating energy. From our innovation, we believe that our biomass batteries are able to contribute to Sustainable Development Goal number 7, affordable and clean energy, which aims to ensure access to affordable, reliable, sustainable and modern energy for all. Basically, the main reason that triggered us to come out with this innovation is to support the Malaysian government, who launched the National Energy Policy 2022 to 2040 (NEP) on September 19, 2022, with the aim of enhancing microeconomics, resilience and energy security, achieving social equitability and affordability, and ensuring environmental sustainability.
Alright, so this is our final product of OPS sugarcane baggers battery. Before moving forward, let's take a look on how a dry cell operates. Firstly, a dry cell consists of three main components, that is an anode, zinc, a cathode, carbon rod, and an electrolyte that is a mixture of sodium hydroxide, manganese dioxide, and carbon that is obtained by biomass source. The carbon acts as a conductor to the oxidizing agent and does not react with the electrochemical reaction that produces electric current. The chemical reaction in voltaic cell results in electrons that are able to carry charges from the negative terminal to the positive terminal. The movement of electrons generates electricity and completes the circuit. This whole process is known as redox reaction, where oxidation and reduction occur simultaneously. Over here is the chemical equation of reaction that occurs in voltaic cell. Next, we have carried out an experiment to determine the percentage of carbon dioxide released during combustion. We made the mass constant and we measure the time in 20 seconds. As we can see, sugarcane baggers release 49.8% of carbon dioxide during combustion. According to the agency, each kilowatts of batteries produced would generate the equivalent of 150 to 200 kilograms of carbon dioxide. Now, let's take a look on how we determine the percentage of carbon dioxide.
As you can see here, the percentage of carbon obtained from sugarcane baggers after combustion, according to the CHNS analysis, is 51.31%. We have also found a few thesis statements that is able to support our innovation of making batteries from biomass, primarily from sugarcane baggers.
Now, let me show the process of making the batteries. Here are the apparatus and materials that we needed. We need to start with making the standard solution of sodium hydroxide. First, 10 grams of sodium hydroxide was weighed. Sodium hydroxide was dissolved and diluted using distilled water, and distilled water was added until it reaches the calibration mark. 1 mole of sodium hydroxide was prepared.
As for the process of making carbon from biomass source, sugarcane baggers was collected and dried, cut into small pieces, and then it was burned directly using Bunsen burner. After that, to obtain carbon from biomass source, the burnt biomass was mashed using mortar and pestle. all the product was sieved in order to obtain carbon. Next, we move on to prepare the dry cell. First, we draft the battery casing. Zinc sheet was cut according to the measurement, and then we make a hole at bottom of bottle and cap using solder. And finally, we put carbon rod on center. To complete the process of preparing the dry cell, manganese dioxide and carbon were weighed. The materials were mixed and weighed using 1 molar sodium hydroxide. The electrolyte paste was poured into the battery casing and the voltage and current readings were measured.
Based on our innovation, it is also found that there's commercial value. For instance, this innovation is able to ensure that batteries can be bought at an affordable price. Besides that, this innovation is also eco-friendly and also able to create new job opportunity for the local community and also able to improve the economic growth. As mentioned before, this innovation ensures batteries can be bought by the people at an affordable price because based on our pricing, it only costs about 2 ringgit 85 cents, which is significantly cheaper compared to normal batteries that cost around 35 ringgit according to our research. This innovation was assisted by once again mentioned Dr. Noor Nadia D. Zulkifli in collaboration with UiTM Pilar, and this innovation has been also validated by an expert as shown. We were also able to successfully obtain gold when competing in Matriculation Science Carnival Moscow in Penang.
In conclusion, through various analyses, it can be concluded that hard carbon obtained from biomass sources holds great promise in fulfilling the requirements of good performance and sustainability of a normal fossil fuel-made battery. Lastly, we are the Oppenheimers. Sugarcane is more power than you think. Thank you.